Hi everyone, as requested, welcome to my Edexcel GCSE Maths Paper 2, which is a calculator paper in the higher tier. What we're going to do is work through the whole exam paper. I'm going to pretend that I'm you sat in the exam attempting the paper that you are going to have to do. I've got a calculator in my hand and I'm ready to go. How I advise that you use this video is pause on each question, have a go yourself, then press play again and see what I've done. Now, I'm not perfect, I may make some mistakes, but I'm going to try my very best to get 100%. So let's go. There's the formula sheet. In the non-calculator paper, we didn't need to use it, but I imagine we might need it in this paper. Question 1. Here is a cuboid. Now, what some people do, as soon as they see a cuboid, is they start answering the question without even reading what you have to do. Okay, the cuboid's dimension is 6 by 1.5 by 1.5. So like I said, some people think cuboid times them all together. No, that's for volume, and it depends what it's asking you to find. This question wants a total surface area. So that means, I always say, how much wrapping paper do you need to wrap up the whole cuboid? Okay, if you imagine it as a box. So I'm going to highlight on the screen and we're going to find each area. This area. So it's just a rectangle. So to find the area, we're going to do the base times the height. The height is 1.5 because these are all the same heights. So we're doing 6 times 1.5. We have a calculator now, but we should be able to do that anyway. 1.5 lots of 6 is 9. Now, this is the bit where you have to picture what's going on. You know this area here? This area is also on the back. And if you did a see-through shape, you would see where I'm talking about. Okay? So this area is at the front, and the same one is at the back. And if you're good at 3D drawing, you'll understand what's going on there. So what I'm going to do, each area I find, times it by 2, which is 18. And then I put that in a circle. So we've done this one, and we've done the one behind. Now, our next area is the one on the side. So let's show that on highlighter pen. This area is 1.5 across, 1.5 up. So 1.5 times 1.5, probably on your calculator, gives you 2.25. Now what we talked about was this area is the same as the opposite area in a cuboid. So you're going to multiply by 2. When you multiply by 2, you're going to get 4.5. So you put that in a circle. 4.5, showing you're working out. You may do your working out here, it doesn't really matter as long as it's clear. The final area we're going to find is the top. Now if you were looking like a bird's eye view from the top, you would see this as just a normal rectangle like this, okay? It's just because of perspective it looks slanted. So this rectangle is 1.5 across and 1.5 up and 6 across. It just so happens to be the same as the front area, but I didn't show you that because it's not always the case. You can't assume that. So, same as before, 6 times 1.5 is 9, times by 2, we get 18 again for the top and the bottom. So we should have found 6 areas in total, or 3 and then doubled them. Now you have to add up 18 and 4.5. You do have a calculator if you don't want to do that yourself, but you should get the answer of 40.5. And always give your units. Units, because it's 3D, aren't necessarily centimeters cubed. We're talking about surface area, and each area we got was in 2D. So when we're imagining the wrapping paper to wrap up the parcel or present, then it's flat when you lay it out, so it's centimeters squared area. That's question 1 then. Moving on to question 2. Okay. Question 2 is a starred question, which means it's functional. You need to show clearly how you got your answer. Okay, you can see the star there. So we've got some ingredients for making 18 mince pies. Must be Christmas time. Here's a list of ingredients. I'm not going to read that out for you. You can see the table. Elaine wants to make 45 mince pies. From knowing the ingredients for 18 that's in your recipe book, and we want to make 45. So what we want really is a trick using times or divide, or both, to get from 18 to 45. Now I've been practicing maths for a while, so I can see that if we divide by 2 to get 9, and then times by 5, we get it. So I can see the trick, divide by 2, times by 5. Now you might not see that trick, so I'll show you a way to do that. 45 divided by 18, and you get 5 over 2, which is the same thing. So for each of your ingredients, if you times by 5, divide by 2, which is the same as on your calculator, times 5 over 2, you're going to get how much you need of each ingredient. So the first one, 225, times by 5 over 2, you can use your fraction button, and you get, in decimal form, 562.5 is how much butter we need. We'll come to check in a minute. Flour, we're going to do 350 times by 5 over 2 again. And we're going to get 875 grams of flour needed. Sugar, 100 times 5 over 2. 250 grams of sugar needed. Mincemeat, 280 times by 5 over 2 equals 700 grams of mincemeat. And eggs, 1 times 5 over 2, 2.5 eggs. Okay, so basically you need 3, don't you? You can't have 2.5 eggs. So we're going to check each ingredient and see how much we've got, how much we need. We've got 1 kilogram, which is 1,000 grams of butter, and we only need 5,625 grams, as we can see here, so that's enough. Okay. We need 1,000. We've got 1,000 grams of flour. We need 875, so we've got enough. We need 500 grams of sugar. We need 250 grams of sugar. We've got enough. Now we've got a problem. Even though we've got enough eggs, we do not have enough mincemeat. So now we explain what we found out. We need 700 grams of mincemeat and only have 600 grams, so we do not have enough. Okay, you explain clearly that you don't have enough and why. You've said what you need, you've said what you've got. Okay, moving on to the next question. That one was 4 marks. Question 3, we have a scatter graph showing information about 10 cars. They're the same type and model and make of car. Graph shows the age in years. You can see the age going across the bottom and the value of each car. So the value is here on the y-axis. The age in years is on the x-axis. Now, let me guess, it's going to ask about the pattern. Yeah, in a minute, describe a relationship and an estimation. It's a standard question on scatter graphs. So, do not miss this question out. There's a bit of a table here, and it says there's two other cars where we've got the information on it. 1 year it's worth £8,200. 3.5 years is worth £5,000. Plot the information from the table onto a scatter graph. So let's look at 1 year, 8,200. We go to 1 year, we go to 800, we think about the scale. That's from 8,000 to what? 10,000. So we need 9,000 is halfway. So that means this needs to be split up 200, 400, 600, 800, 1,000. So each little square is worth 200. So we just plot that information on and we go 8,200, done. Okay, next one, 3.5 years and £5,000. So 3.5 is here and 5,000 is between 4,000 and 6,000. So we plot it there. Okay, done. Describe the relationship between the age and values of cars. Now, if I was sat at my exam desk doing my exam paper, I would now get out my ruler and try and draw a line of best fit that has the same number of points below it than it does above it, okay? So do your best to draw a straight line with your ruler through the middle of those points. That's not bad, I don't think. You can see the line from left to right is going down. Okay, so that's negative. If it was going from left to right up, that would have been positive. And what we're talking about is correlation. Okay, so it's negative correlation, and in context, the relationship between the age and the value of the cars is as the age increases, the value decreases. Okay, can you see as the age goes up, it's coming down like we talked about, negative correlation. So that would get you the marks. Next part. A car of the same type and make is 2.5 years old. Estimate the value. The reason it says estimate is that everyone's graph will have a slightly different line of best fit on. So it's just an estimate because unless you've used a computer program or a formula, your line won't be perfect. Any line of best fit around the center of the points will get you the mark. So you go to 2.5 years, you go up, you can show the examiner you're working out, there's nothing wrong with that. In fact, it's good. You go to your line, best fit, we go across, being as accurate as you can. Now can you see we've gone 6,000 and then 200 up and then halfway of 200 to get 6,300 as our estimate. Okay, and in these questions there's always a range, so don't worry about your line of best fit as long as it looks good. Okay, I think that's it, so clear the ink. Yeah, next question. Rihanna plays a game. Hope it's a fun game. The probability that she will lose the game is 0.32. The probability that she will draw the game is 0.05. Rihanna is going to play the game 200 times. Work out an estimate for the number of times Rihanna will win the game. What you need to know is if you have all the possibilities of an event, then all their probabilities must add up to 1. Because it's certain that at least one of them will happen. So imagine she's playing a game. She can either win, lose, or draw. We already know that a win is what we need to find out. The probability of a losing is 0.32. Probability of a draw, 0.05. So this number here has to add up to these to make 1. So on your calculator, 1 take away 0.32, take away 0.05, gives you the answer of 0.63. Okay, that's the probability of a win. Now, I see some really interesting answers here. Remember, it's like a real life situation. You're playing a game 200 times. So don't you dare write down an answer of, say, 0.63 or 1020. Well, because they don't make sense. You can't win a game 0.63 times in real life. You can't win a game 1020 times if you're only playing it 200 times. Makes sense. So your number has to be between 0 and 200. Anyway, less about how not to go wrong, more about how to get the answer. If I said this was a half, just to explain what's going on, then if you play it 200 times, you'd half it to get the expected 100 times winning. It's not a half, it's 0.63. But you do the same thing. You do the number of times that you play, times by the probability, 0.63, on your calculator, and it gives you 126. And you check yourself, yeah, that makes sense, 126 wins out of 200. Okay, done. Anyway, clear that ink. Number 5. Mason is doing a survey to find out how many magazines people buy. You wouldn't believe it, but I've seen people on these questions be like, oh, how many magazines do I buy? Yeah, 4 to 8. No, come on, let's be sensible. That's not what the question's asking. He uses this question in his questionnaire. Write down 2 things wrong with the question. Okay, now, very important thing. Imagine you are answering it. What's wrong with it? If you were trying to think where to put your answer. What if your answer was 4? You wouldn't know which box to tick. Do you tick that box or that box? Same with 8. Do you tick this one or this one? So one thing is options overlap. I.e. or e.g. 4 is in 2 boxes and 8 in 2 boxes. Okay, so that's one thing wrong. The next thing is there's no time frame. How many magazines do you buy? How do I know if that's in your whole lifetime or if it's just in a day or in a week? No time frame. E.g., always give an example. I can spell frame, honestly. E.g., what were we going to say? Per week, stroke month. Okay. Now, all these things you're writing wrong, you're going to need in a minute when you write a better one. And just in case you're wanting more, there's no option for over 12 magazines. Okay? So, write a better one. Use this, but improve it from what we've just said here. So, how we're going to add our bit on now of per week. Sorry about that. I don't know what just happened there. Oh, I know. It's exited the full screen mode. Okay. Per week. And we need to give options. So 0 to 4. Do not overlap. We've just said that's wrong. 5 to 8. 9 to 12. And we want 13 plus. So we cover all possibilities. Okay, done. Is there any more on that? Yeah. Okay, well, we don't need the previous one. We can clear that ink. Mason asks his friends at school to do the questionnaire. This may not be a good sample to use. Give one reason why. With a sample, you want it to be representative and give you information from all sorts of people, okay, that you're investigating. Now, he wants to find out how many magazines people buy in general. So he's only going to be asking certain people a certain age range, so it's going to be biased. And another reason is, if it's only his friends, unless he's Mr. Really Popular, knows everyone in the country, okay, sample will be too small if he just asks his friends. Does that make sense? You'll notice that sometimes I do a bit more work than is required just for you learning the questions, basically. So you've got a choice of what to put. Okay. Next one. Let's clear that off. Question 6. Tame Valley is a company that makes yogurts. A machine fills trays of 20 pots with yogurt. So each tray has 20 pots in. Okay, if you imagine them all. Okay, 20 pots. In 1 hour, the machine fills a total of 15,000 pots 1 hour. So I'm just writing down the key information. You can see where I'm getting it from. Work out how many seconds, we're changing to seconds, the machine takes to fill each tray of 20 pots. Now this is a complicated wordy question, so I'm going to read it again because that was what I would do in my exam. Tame Valley is a company that makes yogurts. Who cares? Come on. A machine fills trays of 20 pots with yogurt. Okay? In 1 hour, the machine fills a total of 15. So, 15,000 pots in 1 hour equals 15,000 pots in 60 minutes equals 15,000 pots in, we want to change minutes to seconds now, so we're going to times by another 60, 60 times 60, 3,600. So we're in the right format now. We're in seconds like we wanted. Now we want to know how long to fill up a tray of 20 pots. So we're going to see how to get from 15,000 to 20. So on your calculator, do 15,000 divided by 20 and you get 750. So that means if you divide 15,000 by 750 on both sides of the equation, you're going to get your answer for 20 pots. So 3,600. So your answer is 4.8 seconds. Okay, moving on. Let's just check we've got that right. How many seconds does it take to fill up each tray? Yeah. Okay, question 7. Colin, Dave and Emma share some money. It's nice of them. Colin gets 3/10 of the money. Now always use C for Colin, E for Emma, D for Dave, etc. to save your working out time. Emma and Dave share the rest of the money in the ratio 3:2. So Emma wants 3 parts and Dave wants 2 parts, so they have to have a total of 5 parts to share. What is Dave's share of the money? So, if we take 3/10 of the money, what we're going to have left if we're taking, well, we start off with 100%, so 10 over 10, we're left with 7/10 to share out. Okay, this is quite a tricky question, 4 marks. Now, we want to think about, well, we're sharing it between 5 parts so that Emma can have 3 of each, Dave can have 2 of each. So imagine that you've got £5 coins. Emma is going to get 3 of them. Lucky girl. Dave is going to get 2 of them for every £5. So imagine that you are actually in this situation with your friend. You'd get all your £5 and take 3, 2 in that ratio. That's what it means, okay? Now, if I can do a cloner on this, that would be pretty cool. But unfortunately, I don't think I can. What I was going to do is copy and paste all the way down with this pattern until we got up to how many we needed. So 7 over 10 is the same as 70 out of 100. Now we need to think, if we've got 70%, we need to share it in the ratio 3 to 2. So on your calculator, if you do 70 divided by 5, you get 14. So there's 14 parts to share. Remember, each part is a 5. So Dave gets 2 of the parts, so Dave gets 14 times 2, 28, and remember it's out of 100, so it's 28 over 100, aka 28%. I know that's quite a tricky functional question. I hope I've explained it clearly. If not, you can always ask a question like some of you have done. I may have a video, which is good. Right, diagram shows a plan of a playground. Bill is going to cover the playground with tarmac. It costs £2.56 to cover each square metre with tarmac. Work out the total cost of tarmac Bill needs. So, if we know per square metre, we need to know how many square metres are in this diagram. Now, it's a tricky shape, and we don't know how to find the area of that particular shape. But what we do know how to find the area of is a rectangle and a trapezium, or you could even split it up again, 2 rectangles and a triangle, which is what I'm going to do. So, let's do this one I've outlined in red first. The area is 40 times 60, base times height, which is 2,400 meters squared. Next rectangle, base times height. Well, what is the base? If you think it's 80 all the way across and 40 across here, do 80 minus 40 tells you that this is 40 as well. So you're going to do 30 meters times 40 meters, which is going to give you 1,200 meters squared. Okay, if you notice, that's half of this, isn't it? Next one, a triangle. This 50 is a bit of a red herring, to be honest, which means you don't actually need it. For an area of a triangle, you do half times base times height. Okay. The base, if you imagine it spun around, is... I need to stop doing that. I'm thinking I'm on my other board where I can spin shapes and it's pretty cool, but I'm a bit restricted here. 60 all the way, 30 to here, so 60 take 30 means our triangle is like this, 40, 30. So you're going to do a half times 40 times 30, which is going to give you 600 meters squared. So now you're going to add up those values, 2,400 plus 1,200 plus 600, and that's going to give you, you don't really need a calculator for these, but if it's a calculator paper, I recommend that you use it. the area. So the area equals 4,200 metres squared. It costs £2.56 per metre. So the cost you're going to get by doing 4,200 times by the cost of each one. So now you need your calculator, 4,200 times £2.56, and it gives you an expensive cost of £10,752. Okay, that is the total cost. Moving on. Question 9. Oh, that looks tricky. Okay, a lot of wordy stuff in these questions. Most of the time they're just telling you what's in the diagram. Sometimes they give you a little bit extra too. So ABC is a straight line. Told you, it tells you in the diagram. We can see it's a straight line. PQR is a straight line. AQD is a straight line. Wow, it's incredible. So we know all that. ABC is parallel to PQR. Now, if we know these signs, we know that means parallel as well. Angle BAQ is 35, shown on the question. BQA is 90, shown on the question. Our challenge is to find this angle X. So let's think about how we're going to do this. Can you see the parallel lines? You might have been taught parallel lines across like this. It doesn't matter if you spin them round. You're looking for Z's and you're looking for F's. Okay. Now, can you see the Z that we've got here? It's a Z angle. So that means this green one is the same as what X is. And can you notice we've got a triangle here, which is a right angle triangle. So we're going to think, well, this is 35. Angles in a triangle, 180 degrees. So we're going to do 180, take away 90, take away 35, which gives us the answer here of 55 degrees. Now, if that's 55, then this angle here is 55 degrees. If you read the question, it says give reasons for each stage. Okay, so let's go back through what we did and give reasons. First thing we did was angles in a triangle, add to 180, and this 3 dots means that therefore it's a short way of writing that, or so, or implies that. Okay, so it's just shorthand. Therefore, angle ABQ equals 55. That's how we knew this answer and this answer. Our next stage in our working out was to know that these are the same. Now, Z angles are called alternate. Okay, so we can write ABQ, angle ABQ, equals angle BQR. The way I'm doing this is thinking when I want an angle, I just go, in this case, B to Q to R, and the angle inside is what I'm talking about, since they are alternate angles. Therefore, or so, angle BQR, which is what we wanted, the one marked X, 55 degrees. Job done, and we've given our reasons as well. And that is worth 4 marks. Question 10. Oh, I like these questions. You get a horrible looking equation and you have to solve it. Now, you don't have to solve it with traditional algebra, you'll be glad to know. You have to solve it by guessing. Trial and improvement, which means guessing, basically. You guess an answer, you try and make it better. Give your answer correct to 1 decimal place. So, what I want you to do is think of this as where you're trying to guess the X value, And this is what we're aiming for, our target. So we always set up a table. Basically, we put our guess, or mathematically our x value. Then we work out this bit, what it gets if you do x cubed plus 2x. And then we want to know how close it is to 110. And we're going to say too high or too low. Now, it tells you the answer, x is between 4 and 5. The first guess you should do is halfway between 4.5. On your calculator, 4.5 cubed plus 2 times 4.5. Everywhere you've got x, change it for this value. So I'm going to do this on my calculator now, and you could do the same. So 4.5 cubed plus 2 times 4.5. Don't clear your screen because I'll tell you how to use that again. You get the answer of 100.125. Can I move this across? Done. 100.125, which is too low. So that means we want it bigger, so we're going to increase our guess. Let's increase our guess to 4.6. Now go back into your working out if you can in your calculator and change the 4.5 to 4.6. That's a little top tip to save you a bit of time. So what we've done on our calculator is 4.6 cubed plus 2 times 4.6, and you should get 106.536, which is again still too low. You might be shouting at the screen saying, try higher. Why didn't you try 4.7 before? Well, do apologise. Maybe you would have done that in your exam. Now, 4.7 cubed plus 2 times 4.7. Okay. Still too... Oh, it's too high this time. Now we have a very interesting situation. We've got one that's too low, one that's too high. So our answer is somewhere between here. Okay? Now we want to know, because we're only giving our answer to one decimal place, which one to pick. And the way we do that is we think about in the middle. So imagine on your number line, if the real answer of x is somewhere between 4.6 and 4.7, but we're not sure where, to locate this x value, what we can do, we can figure out 4.65, and if that is too low, it must be here. If it's too high, it must be here. So let's investigate. 4.65. The last one we're going to figure out. 4.65 cubed plus 2 times 4.65. And you get 109.84, etc. That's too low. That means that this value is too low for x, so x must be here. So what we're going to put in our answer is 4.7. Do not put this. This might be closer. However, your answer is only to one decimal place. If you put 4.65, you won't get all the marks, I'm afraid. So 4.7 is our answer. Okay, question 11. We have a right-angled triangle. We want to work out the length of xz, x to z. And we want to give our answer in rounded form to three significant figures. So, you should notice it's a right-angled triangle, and it should spring to mind that we're going to be doing Pythagoras. The way I teach Pythagoras is by using SSAS or SSSS. If you've not seen this before, it probably make will make no sense, but I'll show you what it means. It means square, add, square root. And this means square, subtract, square root. All you need to know is which version to use. Do you subtract or do you add? Well, you know this has got so many S's. This means you want the shorter side. Look at all those S's going on. You can't forget that. Shorter side, S, 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 S. Okay, in this case, we want the longer side. And the longer side is always opposite the right angle. So, the posh word for that, hypotenuse. Not going to write that out. Hypotenuse. Okay, so we're going to do square, 1.35 squared, square, 3.25 squared, add, and then our answer is going to be square rooted. Okay, that's the proper way to write it, but don't worry too much. On your calculator, 1.35 squared plus 3.25 squared. Press equals, then press square root, which is this button, by the way. Might have an empty thing there. Square root, let me find it on my calculator. There it is. Answer, ANS, equals 3.5192, etc., etc. Read the question, 3 significant figures. 1, 2, 3. So we want 3 digits on our answer. Look at the next one. It's a 9, so we round the 1 up. So 3.52. Okay, meters. And that one was worth 3 marks. Moving on to question 12. We have a nice algebra question, and we've got 2 equations to solve by the look of it. When I think about solving equations, I always think about doing the same thing to both sides to get the letter on its own. Now, if you look at the first question, part A, before we do any of that, we have to do half the banana method. So we have to do 3 times x is 3x, 3 times 2 is 6, and it's a minus in front. So we get 3x minus 6. We haven't done anything to the right-hand side, so that stays as x plus 7. Now we've got an equation ready to try and solve. We want to get x on its own, so we're going to try and get our x on this side because that's where most of them are. There's only one x here. So we want our x's on this side and our numbers on this side. The first thing we do is add 6 onto both sides of the equation. So we get 3x and the minus 6 disappears because we've done the opposite. And we get x plus 13. Now we take away we take away x, so it's one step ahead from both sides to get 2x equals 13. Do not panic at this stage thinking, how am I going to do 13 divided by 2? Not only is it a calculator paper, you could also just write it as, instead of divide by 2, 13 over 2. Okay, since you do have your calculator, you might as well do 13 divided by 2 and see that it gives you 6.5. Okay, part B. We want to do the same to both sides of the equation. We're trying to get y on its own. At the minute, it's being divided by 5 as the main thing being done to it. We need to get rid of this. Divide by 5 that's happening to the whole side. So we do the opposite of divide by 5, which is multiply by 5. So we get left on the left-hand side of the equation with 2 minus y. Because if you divide by 5 and times by 5, you get the same thing. A billion times by 5 divided by 5 is a billion. Okay? So 2 minus y equals 5. Take away 2 from both sides of the equation, minus y equals 3. And then here's the trick, times by minus 1. As our answer. Okay. Moving on to part 13. We've got a set of axes and we've got 2 points plotted. Find the coordinates of the midpoint. And then we've got 2 more points and we have to find a gradient. Okay. So we want to find the middle of A and B, the midpoint. Now I'll show you how to think about this as a diagram. If you go so we need to think, well, how far across is this? This is from minus 1 to 7. If you want to find the middle of minus 1 to 7, it goes 8 across, so the middle is going to be at 3. Another way to do this, a quick trick for you, is add them together. Half it, 3. Okay, we get the same thing. I'll show you the quick trick for the second one as well. Looking at our y values, 2 add 5 equals 7. 7 divided by 2 is 3.5. So 3.5 is your midpoint. Okay. Part B. We do not need the diagram for this one, so we're going to clear the ink. P is that point and Q is that point. The gradient of PQ. What you want to think about is change in y divided by change in x. If you don't know this formula, you need to learn that formula for gradients. Okay, so the change in y, what are we talking about here? Well, you want the point on the far left side, which the first point to come to is this. Okay, so imagine that that's here somewhere, minus 4, 4. We're not being fully accurate. And then we go to 1 minus 5. So we go here somewhere. Okay. So what is the change in your y values to get from 4 to minus 5? Okay. Well, to get from 4 to minus 5, you do minus. Same thing for your x values. You're going from minus 4 to 1. So from minus 4 to get to 1, you have to add 5. So your answer is minus 9 over 5. Do it on your calculator. Minus 9 divided by 5. And you. So thinking about that value, minus 1.8. Just check we've done it right. 4 to 5 is 9. Yep. Minus 4 to 1 is 5. So that's fine. Okay. Question 14. You can see it's a starred question, so you're going to be assessed on how well you explain your answer. Be very careful. Viv wants to invest £2,000 for 2 years in a bank. She's got 2 choices, the international bank or the friendly bank. At the end of 2 years, Viv wants to. So we need to compare the 2 accounts. I'm going to do the working out for the international bank in red. If you want in your exam, you can just split your page in half and compare on each side. We're going to work out how much money she gets from the international bank. You could call it I, couldn't you, for international? So we're going to think about compound interest, and that means that it gets added to your current amount. So for example, compound interest, you might start off with 100 quid and get 10%, so next year you've got 110. If it was simple basic interest, you'd just keep getting £10 every year. But with compound, you get 10% of the 110, so you get £11 interest as well. That is the difference. Okay. So compound interest, you start off with £2,000, and you get 4% for the first year. Now a trick that I'm going to show you, if you want to add on 4% to 100, you want 104%, don't you? 104% as a decimal is 1.04, and that's called our multiplier. So we do 2,000 times by 1.04 on our calculators, and we get 2,080. That's the first year. 1% each year after that. So we want to add on 1% to 100%. So we want to find 101%. So our multiplier this time is 1.01. Just change it to a decimal. So 2080 times by 1.01. If you've still got it on your calculator as the answer, you can use that. And you get £2,100.80. Looking at the friendly bank, let's do this working out in blue. Again, it's compound interest. She starts with £2,000. She gets 5% for the first year. Hopefully you understand what I've done with the multiplier, and you can see we can just times by 1.05. So 2,000 times by 1.05, and you get 2,100. That's the first year. The next year we get 0.5%. That's harder to change to decimal because it's 0.005 is half a percent, and then we're adding it to 1. So it's times by 1.005. Do that on your calculator, and you get the answer of £2,110 and 50p. So you're better to go for the friendly bank, and you do need to make that explicit because you get more money there. Right, moving on to question 15. That one was 4 marks. 15, we've got a table to complete, and our graph is a quadratic graph. I can see that because it's got x squared in, and I can predict the future and think that it's going to be a curve shape. It might be like that, it might be like that, if you know what quadratic graphs look like. Anyway, I'm going to start off, as I usually do, with the easier values of x. So I'm going to start off with 4. I don't want to start off with a negative. And on your calculator, you need to put, instead of x, 4 in each time. So to get y, you do 4 squared, take away 2 times 4. So 4 squared, take away 2 times 4 is 8. 3 is done for you. 2. So instead of 4, you're putting 2 in. So 2 squared, take away 2 times 2, should give you 0. Now you're putting 1 in. 1 squared, take away 2 times 1. On your calculator or in your head, 1 take away 2 minus 1. These are done for you. Now can you see why I did the harder ones first, the easy ones first? Because now I can see a pattern. 8, 3, 0 minus 1, 0, 3. This is going to be 8. But let's just check. You don't just take my word for it. On your calculator, in brackets now, minus 2 squared, take away 2 times minus 2. And you do get the value of 8. So I'm just going to write these on so when I scroll down we can still see them. And we want to plot these values now. Okay, so x minus 2, y is 8. There you go. Minus 1 and 3. Halfway between 2 and 4. For 3, 0, 0. 1 minus 1. Halfway between 0 and 2. Just there. Maybe a little bit higher. Okay, it's hard to be very accurate with this software. Next one, 2 and 0. 4. Next one, 4, 8. Now what you have to do is draw a very smooth curve. It's going to be this curve. It has to go through all your points and be a nice U shape. So freehand, turning just like that. Okay. If you want to show off, you can label it as well. So that green line is our equation y equals x squared minus 2x. Now can you see we've got again x squared minus 2x minus 2 equals 3. What is repeated here is that x squared minus 2x. Okay, this green line is this equation. So if we keep this on this side, and if we add on the 2 to give us x squared minus 2x equals 3, there's a little trick we can do. This is y equals x squared minus 2x. If this is y equals 3, when you put them together, you get the answer of this, which goes to that. So what I'm trying to say is, if you've got an equation on the left-hand side and an answer on the right-hand side, you can draw both graphs and the answer is where they intersect. So y equals 3 is here. Draw a line across. Or you didn't even have to draw a line if you're very smart and on the ball, because you can think when y is 3, it's in our table. So x equals minus 1 or x equals 3. You've got two answers since it's a quadratic. Yes, you could have done that by taking away the 1 and then factorising. You'll still get the same answer. I just wanted to show you what the question was trying to get at. There's not always one way to do these things. Question 16. It's a circle theorem question. So you have to find the size of the angle marked x, which is here, and you have to give reasons for each stage of your working out. Give reasons for your answer. So, one thing we should know, if we've got a tangent to a circle, it meets at 90 degrees. So we can write that down. Tangent meets radius at 90 degrees. Okay, so that's that bit explained. Now if you look at the triangle we can form, so right angle triangle with a 90 degree angle there, 32 there, missing angle here. So on your calculator, 180, take away 90, take away 32, and that gives you 58 degrees for angle TOP. Top equals 58 degrees, since angles in a triangle add to 180. Now the next stage is quite tricky. You need to see that because that joins the circumference to the centre, that's a radius, and so is this one because it joins the circumference to the centre. So the type of triangle we have here is an isosceles triangle. So let's take it to one side. It's an isosceles triangle, which should make the question a lot easier. We want the value x, which is the same as that since it's isosceles. All we need to think about is this angle, and then we can take it from 180 and half it to find x. So how are we going to find this one? Well, angles on a straight line equal 180, or add to 180 degrees. Therefore, this angle here, SOT, equals 180 take away 58, which is 122 degrees. So now back to this question. We can do which gives you 58. Now 58 is for two of your angles, for two x's, so you need to divide by 2 and get the answer of 29 degrees, since SOT is isosceles. Isosceles. Okay? And that's your answer. And that is for 5 marks. When you say it's worth 5 marks, just double check you've given enough reasons. So I might add in at this stage for angle STSO. Did not want to do that. TSO equals angle Right, question 17. Some girls did a sponsored swim to raise money for charity. The table shows information about the amounts of money in pounds the girls raised. Least amount of money was £10, greatest amount was 45, median 25, lower quartile 16, upper quartile 42. Draw a box plot for the information. Right, so least amount of money is £10, so that goes as our minimum here. Greatest amount is £45, which goes as our maximum here. Median is the middle value, which is £25, which is in the middle here. Lower quartile is £16, so 15, 16 goes there. Upper quartile is 42, 41, 42 here. Now to draw the box plot, you have to make the box in the middle and connect like that, and that gets you 2 marks. The setup for the box plot is always the same. It's the min, lower quartile, median, hopefully you can read this okay. Some boys also did a sponsored swim. Now, if we compare, we can put it directly on top. That might be quite useful, if you can see still what's going on. Make these black lines red so it's even clearer. Obviously, you don't have the pleasure of doing this in your exam. You can just compare one on top of the other. Okay. So, compare the amounts of money the girls raised to the amounts of money the boys raised. To get other marks, you have to compare the median and you have to compare measure of spread. Let's say the interquartile range to get both the marks. So, the median of this boys one is 32. So, boys median is greater. Boys median is greater than the girls. So you can write in bracket what the medians are. So the boys median is 32. We also have to explain the IQR. IQR for girls equals, let me remember which one the girls one is, it's the red one. And to get the interquartile range, you have to do the upper quarter, take away the lower quarter. So 16 minus 42, 42 minus 16. So 42 minus 16 gives you 26. And the IQR for the boys, you're going to do 40, take away 18, which gives you 22. So the girls' data is more spread out. So we've compared the median and the interquartile range. So we've done all the things we have to do to get the 2 marks there. Question 18. Nice algebra question. Make P the subject of a formula. So it usually sometimes says here P equals. That's what make the subject of a formula means. Get it, that letter equals something. Doesn't matter what it is. Doesn't have to be a number. As long as you've got that and then some stuff. Oh, and by the way, no P's in there. The only P must be there. So let's get on with it. Let's add 4 to both sides, just like we were solving the equation for P, but we're going to leave letters in there. So we get y add 4 equals 3p squared. We now divide by 3. We're aiming to get P on its own, remember. Divide by 3, and we get y plus 4. A big divide line like that equals p squared. Ooh, nice thing here to test out. Now we want P on its own, so we need to do the square roots, but we also need to remember, say if you had 9 equals x squared, your answer isn't just 3. Your answer for x is plus or minus 3, because both of them work in this x value. So when we square roots, we are going to put a plus or minus sign. Plus or minus the square root of y plus 4 over 3. And that's more coming on to A-level stuff. If you do A-level maths, you'll see more of this plus or minus thing. That's your answer. Question 19. Factorize 6 plus 9x. So let's just move it to the top. 6 plus 9x. We look at the 2 terms and we look at what's common in both. There's no letters common, so we don't have to worry about that. The numbers common in the 3 times table, so we can take out 3. And we need to think, what do we times 3 by to get 6? 2. What do we get times 3 by to get 9x? 3x. What goes in the middle? A plus. So that's your answer. 3 brackets 2 plus 3x. Next question is quite a tricky one. This is actually called the difference of 2 squares. But you could think of this like a normal quadratic. You're trying to, that should be a y, you're trying to add up to 0 because we've got no y's, and you're trying to times to minus 16. This means your numbers must be the same. Timesing to 16 gives you the answer minus 4 plus 4. Or you can just learn to square root the 16 and write 1 as minus, 1 as plus. It's up to you. Next one is a tricky factorize. Factorize 2p squared minus p minus 10. I have a whole big method for factorizing when we have a number in front of a p. Because it's a 2, I'll show you a slightly different way, which is just about guessing. Now we know that to times to 2, the only way to do it is 2 times 1. So we have 2 and effectively a 1. Now we need to guess what goes here and here. So we have to have 2 numbers that make minus 10. So if we think of our 2 numbers, they could be 1 and 10. Obviously 1 plus 1 minus. Plus and minus could be either way. We could have 2 and 5. That's it. Now we need to get to minus p eventually in our answer. Remember, one of them is being times by 2. So if we put minus 2 here, we are going to get, when we do the banana method, like we wanted 2p squared, we're going to get, this might look a bit messy now, but let's go for it, minus 4p. We're going to need something here to get minus 10, so we're going to want plus 5, and then we get plus 5p. Oh, you noticed what I've done, minus 10. Now look what I've done. I was guessing, and I've guessed something slightly wrong, because this gives us 1p. Always check on these. They're tricky. So all I have to change is my signs. Okay? So all I'm going to change is the signs, make the 5 the minus and that the plus. So then we get a plus here and a minus here to get minus 1p. So that is your answer. 2p minus 5p plus 2. I was planning on doing another video to explain this method more fully, because actually the way I do it is a bit different to that. As you can see, it wasn't seamless, but there you go. Moving on to question 20. The diagram shows a ladder leaning against a vertical wall. Sounds like Pythagoras or trigonometry to me. The ladder stands on a horizontal ground. The length of the ladder is 6 meters. The bottom of the ladder is 2.25 from the wall. All this information is on the diagram, apart from this. A ladder is safe to use when the angle marked y is about 75 degrees. So we want this angle to be about 75 degrees. Now, let's take the triangle that we're given and think about the question. So this is the triangle that's involved. The hypotenuse is 6. This is 2.25. Our angle we're interested in is here. So it's trigonometry. You should straight away write out SO katoa to remind you of your 3 formulas. You need to label opposite, hypotenuse and adjacent, and then you need to think about which formula you need. So opposite our angle is O. The hypotenuse, the longest one, which is always opposite the right angle, is H, and the one left over, the one next to Y, is adjacent to Y, is A. Circle the ones you need. We need H because it's 6, we need A. We don't need O because there's nothing there. So that means the one with H and A is K. This is a simple way to remember the formula that cos of the angle, you can use whatever you want for the angle, I usually use theta, equals adjacent over hypotenuse. Substituting in our actual values, our angle is y. So cos of y equals A. Well, A is 2.25 divided by H, and H is 6. So now we want to know what y is, and we've got cos of y. So we need to do the opposite of cos. And hopefully you know the opposite of cos, the inverse of cos, is cos to minus 1. So you find cos to minus 1 on your calculator, and you do it of that whole thing here, 2.25 over 6. So I'll do it at the same time as you. Cos to minus 1, fraction button, 2.25 over 6. Make sure you're in degrees. Yep. Equals 67.976 to 3 decimal places. Now I'd write underneath at this point whether it's close to 75 or not. No, it's not close enough. It's not about 75. It's almost 10 degrees off. So is the ladder safe to use? No, it is not. Or instead of it, angle y. Moving on to question 21 now. In Holborn School, there are 460 students in Key Stage 3, 320 students in Key Stage 4, 165 students in Key Stage 5. Naima is carrying out an experiment, a survey. He needs a sample of 100 students stratified by key stage. So stratified is the key word here. We want a stratified sample. What stratified means is you want a fair representation of people. For example, if you had 20 people, just as an example, and 2 were boys and 3 were girls, sorry, 18 will be girls, won't they? And we want a stratified sample of 2 people. That means we want a fair representation. Would it be fair to take the 2 boys out of the 20 people and say that's your 2 people? No, it wouldn't be fair, because there's way more girls than boys. So your sample, if it's stratified, has to represent the exact number that were in the original group, the population, and has to be the same ratio in your sample. So let's see how we're going to go about that. Our task is to work out the number of students from Key Stage 3 that needs to be. So we don't even need to figure out all the numbers for each year group. Okay. If there's 100 students we want, we need to know, well, how many are in the total population? So we do 460 plus 320 plus 165 on our calculators, and we get that there's 945 students in total. We want to know what fraction are Key Stage 3. So what we do is, it's out of 945, that's the whole school, and the number of students that are Key Stage 3 is 460. If we work that out on our calculator, 460 divided by 945, we get a decimal of 0.48 or 0.49 to 2 decimal places. That is our multiplier now. So we multiply 0.49 by 100, which is our sample size. And there's no prizes for saying what that is. 49 people. So that's your answer for 2 marks. Sometimes they ask you to work out how much for each group as well. But this one, it's just for Key Stage 3. So that's what we've done. This way it's fair, and we've not got too many students from, say, Key Stage 5, when actually they're a minority. Moving on. Question 22. H is inversely proportional to the square of r. The square of r, let's use algebra, r squared. H is inversely proportional. So if we've got h, we draw a little fish sign, which is a proportional sign. It's proportional, inversely proportional, which means that you do 1 over whatever it's saying, like the inverse, reciprocal, and it's inversely proportional to the square of r, r squared. So that means as h is increasing, then the value is getting bigger by a multiplier of 1 over r squared. Now we could have a constant that's multiplying as well. So as an algebraic equation, we write that this means h equals some number, whatever it is, any old number, times by 1 over r squared. That's our main equation. But what we have to do is use the extra information that we're given, which says when r is 5, h is 3.4, and we can use that to figure out k. So taking this equation, we are now going to put 3.4 where h is, as a substitution, and we're going to put 5 where r is, as a substitution. It's 5 squared. So that gives us the equation that 3.4 equals 1 over 25 if we change the order around, times by k. We want to figure out k, so we want to do the opposite to both sides to get rid of 1 over 25. The opposite of dividing by 25 to get rid of it is multiply by 25. If we do 3.4 multiplied by 25, we get 85 over here. So that means that k is equal to 85. What you would do now is change your k to 85, and you've got your answer. H equals 85 times 1 over r squared. Job done. Okay, clear ink. Question 23. Dan does an experiment to find out the value of pi. He measures the circumference and the diameter of a circle. He measures the circumference C as 170 millimeters. So let's get a little diagram. 170 millimeters. But he's rounded to the nearest millimeter. So we'll talk about that more in a second. That's very important. He measures the diameter D as 54 millimeters. And he's also rounded that to the nearest millimeter. Dan uses the formula pi equals C divided by D, which comes from a formula that the circumference is pi times D. And he uses this to figure out his estimate for pi. Calculate the upper bound and the lower bound for Dan's value of pi. Upper bound means biggest possible. Lower bound means smallest possible. Okay. Now, if we want the upper bound, we'll call it UB. That's the biggest possible. What we're doing is C divided by D. Now let's think about C again. C, we recorded on our notebook, however he did the experiment, that he rounded it and got 170 millimeters. Now let's imagine what values could have actually been on his ruler or whatever it was he used to measure it. It could have been anywhere between 169.5, that rounds up, to 170.49999 forever, which we write as 170.49 reoccurring. And any of these values in here, it would have rounded and given him 170 that he wrote down. One little thing, you know 170.49 reoccurring, it's so close to 170.5, the examiner won't mind if you use this too. So it's up to you. This makes it a little bit easier to do the calculations. So, C, we want the biggest value possible, which we're going to use 170.5. Yes, I know that would actually round up to 171, but we've said this is what our true value is, and because the 9 goes on forever, we're going to call it this, and the examiner will know what we're doing. Now we want to divide by the diameter. Remember, we're trying to make this big. Do we want to divide by a smaller number or a bigger number to make our answer big? Well, imagine a piece of cake. If you're cutting up a piece of cake, if you want a big piece, you better make sure not many people are sharing it with you. So that means the bigger the number we divide by, the smaller our answer. So we need to think about the 54 value, and we need to think, okay, well, we rounded to 54, so the lowest it could have been is 53.5, the biggest it could have been is 54.49 reoccurring, which we can just call 54.5, and we're dividing to get a big value, so we want to divide it by the the smallest possible, 53.5. Put that into your calculator, 170.5 divided by 53.5, and you get the upper bound, if you calculated as fractions, 341 over 107, 341, and if you convert that to a decimal, you get 3. How many significant figures do we want to give it to? Dan's value of pi. Well, does it tell us in the question? Just having a quick read. It doesn't tell us how many significant figures. On my calculator, it's saying 3.18691, etc., etc. So we could just say 6, 9 to 4 decimal places. The lower bound, we're going to do a similar technique, but we're trying to get the smallest value possible now. So what we're going to do in our formula is for C, use the smallest value it could have been, which is 169.5, and divide it by a bigger number to make our final answer even smaller. So the biggest number here, 54.5. When we do this division on our calculator, 169.5 divided by 54.5, we get as a fraction 339 over 109, and as a decimal we get 3.1101 to 4 decimal places. So you can see that he's got an upper bound and a lower bound for his answer, and the real answer will be somewhere in the middle of that. Question 24. We have ourselves a triangle, and the question says work out the triangle, the area of the triangle ABC. Now, what you're used to at GCSE for area of a triangle is a half times the base times the height. That's your formula. Now, if you notice, this height has to be the vertical height, okay, or perpendicular to the base. What that means is you need the base, you need how high up it is, and then that's all. In this triangle, we do not know what the vertical height is. So this old formula will not work. Talking of formula, let's scroll all the way up to the front of your paper where the formula is, the formula page, because I want to show you where it is. I told you we might be using it in this exam. We've come a long way already. I know the formula off by heart, so that would have been a bit quicker, but I want to show you here. In any triangle, ABC, if you label it A, B, C, like this, you can find the area of the triangle by doing a half times A times B times sine of C. Now I'm going to show you a slightly different way, which I prefer, but just to show you what your exam book says, BC. Okay, so we've got the formula that we need. It's very clear. The area of the triangle is definitely what we're trying to find. And you'd look back through your exam to the front, and then if I was you, I'd write it on the correct question that you're working on, so the examiner can see you know exactly what you're doing. We're past 16, I think we're on 23 or 24. Be there in a second. Yeah, 24. So, back to our question. Work out the area of this triangle and give your answer to 3 significant figures. Well, your exam has tried to confuse you because can you see down here it told you how to label your triangle and it's labelled it differently because the angle that you want, sine C, is here and yours is at the top here. Do not worry about that because it is the angle C we want and we know the length A and the length B, so we can use our formula. So this is angle little c. So our formula says a half AB sine C, and these are all multiplied by the way. Our A value is 6, our B value is 7, our C value is 60 degrees. So we do a half times 6 times 7 times sine of 60 degrees. And I'll type this into my calculator now. A half times 6 times 7 times by sine 60 equals, as a decimal, 18.18653348. Reread the question, 3 significant figures. So we go 1, 2, 3, put a box around it. This is a number that might change. We look next door, the 8 does round up, so you get 18.2, and your units are therefore your centimetres squared. Now, what I said I usually do it a different way is if you've got two sides and an angle, side 1, side 2, and an angle, then all you have to do, this makes a triangle by the way, no matter where your sides finish, there's only one place that this extra length can go. You do a half times by side 1 times by side 2 times by sine of your angle. So that's how I do it, just in words, and figure that out. All you have to make sure is your triangle looks like this. Okay, obviously you can just use the formula like we've already done. Both ways work fine. So, moving on to part B, work out the length of the side AB, and we're going to need the formula page again. It took a while to scroll up before, so I'm not going to scroll up again. I'm going to try and remember this one. Just check. Yeah, we've got the triangle already. Delete that bit. So your formula on your formula page that you'll be able to see, if you're looking at a paper right now, says the cosine rule. And the cosine rule says that a squared equals b squared plus c squared minus 2ab sine, sorry, I'm trying to remember this right, 2bc cos a. Pretty sure that's your cosine rule. Okay, now we've got our triangle labelled up, but this time we might have to label it a little bit differently. So let's delete our old stuff. Do not worry about changing the letters that you use. Just because the exam questions put a C next to the angle doesn't mean you can't change it. You want an A next to the angle. So that means that you're going to have to change your other one to C. We've just swapped those two over. Now opposite the capital A is a little a, and that is the side that we're trying to find before we change the letter, their A to their B. Okay, so it's labelled A now, and that's how we want it for the cosine. The other ones are going to be B and little c for the lengths, and now we've got all the labels we need to put it into our formula. So a squared is left as a squared because that is what we're trying to find. B we can change to 6. C, we can change to 7. B, we can change to 6. Remember, this is multiply. C, we can change to 7. And A, the angle A is 60 degrees. So, on your calculator, you can work out the value 6 squared plus 7 squared minus 2 times 6 times 7 times cos of 60 degrees. And that should equal 43. Now that is a squared. A squared is 43. So you need to square root, and because it's a length, it's going to be the positive value. Square root of answer in your calculator as a decimal, 6.56. 3 significant figures. Okay? 3 significant figures again. So, 25. I think there's one more question after this. It's either out of 25 or 26 questions. Simultaneous equations, but very difficult simultaneous equations. And to be honest, they look more like an A-level question, maybe core 1, than a GCSE question. Because you cannot use the elimination method from GCSE to solve this one. The reason I know that you can't use the elimination method where you take one from the other is because we've got x squared and y squared. So we need a different technique. The technique is called substitution. So you've guessed it, we're going to substitute one thing into the other. Now, how do you know what you're going to substitute into what equation? Well, you look at your equation that looks easiest. I think we'd all agree that x plus y equals 2 looks a lot easier than x squared plus y squared equals 9. So we're going to choose this equation to rearrange. We're going to rearrange this equation to get y equals. And how we're going to do that is take away x from both sides. And that means that y equals 2 minus x. So y equals 2 minus x is what we're going to substitute in to the other one. So let's write it again. X squared. Now instead of y, you need to put in 2 minus x. Because we're going to be squaring it, you need to put in brackets there. It's very, very important. I'm going to leave a little gap, you'll see why in a second, equals 9. Now, squared means you're doing this times by itself. So whenever you get this, a bracket squared, you can change it to the bracket times by itself. And then you've got a nice double bracket that you can do the banana method on. 2 times 2 is 4. 2 times minus x is minus 2x. Likewise here. Minus x times minus x is x squared. And that's our 2 brackets expanded. The rest of the stuff stays the same. Now we simplify, we collect like terms. We've got x squared and x squared, so we can put 2x squared. We've got minus 2x minus 2x, which we can put minus 4x. And we've got 4 on its own, which we'll deal with in a second, equals 9. How many marks this worth? Because it looks to me like it's going to be very difficult. Yeah, it's worth 6 marks. It's the final question. Okay? So anyway, let's carry on. What we do now is we think we want to solve this equation. Now, can you see it looks like a quadratic, but we can only solve quadratics when they're equal to 0. So we want the quadratic equal to 0. That means we take away 9 from both sides of the equation. And we get 2x squared minus 4x minus 5 equals 0. Now you think, oh, okay, I might be able to factorise. I'm afraid that I don't think that is going to factorise. And the reason I'm saying that is because you're on the calculator paper and they like to ask you to use the quadratic formula, which would be the third time that we've used the formula page on this paper. So, what we need to do is we need to do label up A, B, C. Now A is 2, B is minus 4, C is 5. What we've labelled this up for, I'll just put it over here, is for using the quadratic formula. It's grade A star. If you're not sure about this, I've done a video dedicated to the quadratic formula and how to use it, so you can check that out on my channel. It says x equals minus b plus or minus square root of b squared minus 4ac all over 2a. Now, we change each letter for the corresponding number. So we write it out again. Just going to move this across so we've got a little bit of room. You know where it was, don't you? So x equals minus b. Well, that means minus of minus 4, which is 4. Plus or minus the square root of minus 4 squared. When you do this on your calculator, minus 4 squared, make sure the minus 4 goes in a bracket. If you don't, you'll get the wrong answer, because a minus times a minus is a plus. It should be 16. 4 times 2 times minus 5. Okay? Now straight away I'm thinking, oh, your calculator will do it for you, so I won't ruin the surprise. 2a, 2 times 2 is 4. And we can now put all of that in our calculator. We need to put it in twice. Once with the plus sign and once with the minus sign to get two answers. So let's first do it with the plus sign. 4 plus the square root 16 minus 4 times 2 times minus 5. That's on the top of my fraction, then divide by 4. You can make your calculator look just like this. Okay? Just like this expression. So, for this one we get 2.87 to 2 decimal places. For the plus version, we need to do exactly the same, and the trick is, keep it on your calculator screen. But go back to where you put a plus before, delete it, and put a minus. That's what I always do. And for that answer, you get minus 0.87 to 2 decimal places. So, we've got two answers, but they're answers for x. Okay? This is a very big question. I'm afraid I'm going to have to rub out some previous working out because we've still got to find the y values. So it's a very long, very difficult question. You'll notice I've fortunately left that y equals 2 minus x. That's what we're going to use to find the y values. So x could equal 2.87 or x could equal minus 0.87. When x equals 2.87, y equals 2 minus 2.87 because it's 2 minus x, and we put our x value in. So y can be minus 0.87. When x is minus 0.87, we do y equals 2 minus 0.87. When two minuses are next to each other, they go together and make a plus. So y is 2.87. We pair them up. This x value goes with this y value. This x value goes with this y value. and we put them in for our answer to get ourselves a final 6 marks for paper. So x equals 2.87 and y equals, you have to put them in pairs, minus 0.87. Or x equals minus 0.87 and y equals 2.87. Again, it's been a long journey. We've done a lot of maths, some A-star work and some tricky stuff. I really hope that this has helped you and that you've used it sensibly to help your revision. And I hope you're enjoying maths, because I sure do. Good luck with the rest of your maths work and achieve maths.